In this video, I'm going to show you how you can use a graphing calculator to construct a histogram and a box plot, and then we're going to analyze the data with the statistics. So the first thing we're going to do is we're going to enter the data that we have listed here in our graphing calculator. So to do that, we're going to click Stat, and where it says Edit, we're going to click Enter, and we want to make sure that all of our lists are clear. If there are numbers in there, just go all the way up to L1, hit clear, and enter. Now we're just going to type in all of our numbers. So we hit 10, enter. So after every number, hit enter so it goes into our table. So we got 3, enter, 27, enter. We got 13, enter. We got 34, enter. We got 1, enter, 6, enter, 14, enter, 8, 4, 52, 22, 40, and 25. Once we have all of our data into our table, we want to set up our histogram and box plot. And we could do these both on the same screen. So to do that, we need to turn our stat plot on. To do that, we're going to hit second, y equals, and you'll notice that I have plot 1, 2, 3 off. So I'm going to go to stat 1. I can hit enter. I want to turn that one on, and I'm going to make this my histogram. So if I go over and then down, the histogram is the one with all the bars. So I'm going to hit enter. I just want to verify that I'm using the X list where I put my data in, which was L1. Now I'm going to go back up to my plots, and I'm going to turn plot 2 on, and I'm going to make this my box plot. To do that, there are two box plots here. There's one right here, and then the second one right here. This one shows the outlier if there's an outlier. This was just the regular one. I'm going to use this one with the outlier one, whether we have an outlier or not. So we're going to highlight that one and hit enter. Again, this is going to be L1. That's what we want. Now that I have that, I'm going to go to my Windows setting, and I want to make sure that all my numbers are going to appear in there. So my X minimum, I'm going to look at my smallest number. My smallest number is 1. So I'm going to make my X minimum 0. My X maximum, so I'm going to look at my biggest number. The biggest number I see is 52. So I want to go, I'm going to say the nearest multiple, or the multiple of 10 that's bigger than 52. I would say that's 60. So I'm going to make that 60. So all my numbers are in that range. My X scale, so if we're thinking about our histogram, how wide is our bin? I'm going to make these 10. So the interval is 10. And then my Y minimum, I'm going to make that 0. So this is talking about like how many numbers would appear in each bin. So a minimum of 0 and a maximum. I'm gonna change this to give me a little more space. I'm gonna put this at 20. And I don't need to worry about the scale. Um, I'll just keep that at 1. Now if I hit graph, you'll see I have my scatter plot, or not my scatter plot, my box plot up here, also known as your box and whisker plot. And then I have a histogram down here. Now, depending on what you do your intervals as for your X scale, that will determine how many bars you have. So if I made it the number bigger than 10, then I probably would have fewer bars than what I have here. And if I made the number smaller, I would have um, more bins. But this one looks fine to me right here. And now we can describe the shape of the distribution. And the description can be either symmetric, which means the tall bars are in the middle and they have the smaller bars on the outside. Or if you think about the box plots, the whiskers are the same distance or the same length. You could also have uh, a negative skewed negatively, which means we have more numbers to the right, so more numbers over here than we would have on the, so more numbers bigger than we have smaller. But this one is not that case. We have more of our numbers on the low end. So this would actually be showing this is positively skewed because we have fewer numbers over here, which means my average is going to be, or my mean is going to be higher than my median because the median is going to be more towards the left because that's where more of our numbers are. Now, if you look at the box and whisker plot, the longer whisker is showing which side it is skewed. So it is skewed on the positive side. So this would be positively skewed. Now, how would we describe the numbers? Now, there are different ways of describing them. If the data is skewed, you're going to use the 5-number system or the 5-number summary. And the 5-number summary is like your minimum, your quartile 1, your median, your quartile 3, and your maximum. If it was a mean and standard deviation, you use those only if it's symmetric. But I'll show you how to find all of them in this video. So to find all the numbers, the data, or the statistics for this, we're going to hit Stat, go over to Calculate, and we're going to go to one variable stats and hit Enter, and then hit Enter again. And this gives us all the data that we need. This X with a bar at the top, that's our mean or our average. And it says our average is 19.3 repeating, so we would say like 19.3. The standard deviation we're going to be looking at is this last one right here where they have the sigma x, and that says the standard deviation is 14.7. Now, if I scroll down, I can see the 5-number summary, which the minimum is 1, the quartile 1 is 6, and the quartile 1 is the first part of our box in our box and whisker plots. Or if you think about it, it's the median of the first half of our data set. Then we have the median of the whole data set, which is at 14. Quartile 3 is on the far right-hand side of the box in the box and whisker plot. Or you can think about it as the median of the second half of our data sets. And then our maximum is 52. Now, another thing you can think of or look at is the median, compare the median and the mean. The median was 14 and the mean is 19. So if the median is to the left of the mean, that means it's positively skewed. If the median is to the right of the mean, then it's negatively skewed. And if the median and the mean are pretty much the same, so I would say if they're within 1 from each other, then we would consider them the same and that would be symmetric. So that is how you can create a histogram and a box plot from data and describe the distribution, and then using the statistics to describe the data set.